Hello friends, welcome to my channel Civil Methods. In this video, we will learn hydrostatic pressure. The hydrostatic pressure or the pressure obtained by using hydrostatic law at any point in the static fluid or fluid at rest is known as hydrostatic pressure. Now, hydrostatic law. What is hydrostatic law? According to the hydrostatic law, the rate of increase of pressure in vertically downward direction for static fluids must be equal. It must be equal to the weight density, or we can say specific weight of the fluid at that point. Now, this is the fluid at rest, and this is the free surface of the fluid, and PQRS is the small fluid element, and delta Z is the height of the fluid element, and distance from free surface is Z, and delta A is the cross-sectional area of fluid element. This is the delta A cross-sectional area. Now same for SR. If P is the pressure at PQ phase, and now this will be P plus del P divided by del Z into delta Z, but in upward direction. Okay. PQRS, sorry. Now force on the face PQ, because pressure is defined as force per unit area. So force is equals to pressure multiplied by area, and pressure at face PQ is small p into area of face PQ is delta A. Now force on the face RS, again with the same formula. This time pressure is P plus del P divided by del Z into delta Z, and again area is the same, delta A. Now weight of the small fluid element, small w, is equals to mass into gravitational acceleration, and mass is density of fluid multiplied by its volume. and we can write volume as multiplication of area into height of the small fluid element is delta z to g. The force at PQ is P dot delta A and force at RS is P plus del P divided by delta Z into delta Z into delta A, and W is the weight of the fluid element acting from the centroid. Now by the free body diagram of the small fluid element, here W weight of the fluid element is in vertical downward direction and P dot delta A is also in vertical downward direction, and force at RS is in vertical upward direction into delta A. Because sorry because fluid at rest for vertical equilibrium, summation of forces in y direction should be equals to 0. Taking vertical forces in upward direction positive, so this force will be positive. P plus del P divided by del Z into delta Z into delta A, negative W because it is in downward direction, and negative P dot delta A is it is in also downward direction. By solving this, P dot delta A to P dot delta A cancels, and now W weight of the fluid element is equals to rho into delta A into delta Z into G. Rho into delta A into delta Z into Z. Del Z to del Z cancels, del A to del A cancels, and del P divided by del Z is equals to rho G. And this rho G is equals to the weight density of the fluid. So according to hydrostatic law, must be equals to the weight density of the fluid at that point. Thus this is the proof of hydrostatic. By hydrostatic law, del P divided by del Z is equals to rho G. Now del P is equals to rho G into delta Z. Integrating both the sides. Now by this, P is equals to rho G Z, where P is equals to hydrostatic pressure at Z depth, and Z is pressure head, Rho is density of fluid and g is gravitational acceleration. Now to solve the problem, an open tank contains water up to a depth of 5 meter and above it an oil of specific gravity 0.9 for a depth of 2 meter. We have to determine pressure intensity at the interface of the two liquids and pressure intensity at the bottom of the two tank at bottom. Okay, this is the interface of the two liquids and this is the bottom of the tank. Now because the specific gravity of oil is equals to 0.9 and specific gravity is defined as density of oil divided by density of standard liquid, and generally the standard liquid is water and the density of water is 1000 kilograms per meter cube. So the density of oil is equals to 0.9 into density of water 1000 kilogram per meter cube and equals to 900 kilogram per meter cube. Is equals to rho 1. Rho 1 is density of oil is 900 kilogram per meter cube and rho 2 is the density of water and it is fixed and equals to 1000 kilograms per meter cube. First, we have to determine the pressure intensity at the interface of the two liquids. By using hydrostatic law, the pressure at depth P at interface is rho 1 into G into Z1. Z1 is the depth is equals to 2 meter. So rho 1 is 900, G is gravitational acceleration 9.81 and Z1 is equals to 2 meter and Z2 is equals to 5 meter. So Z1 is 2 and this will be equals to 17,658 Newton per meter square. For pressure at bottom, it will be equals to the pressure at the interface of the two liquids plus the pressure due to this quantity of water is equal to rho 2g z2 and P internal we already determined plus rho 2 1000 into 9.81 into 5 and total will be equals to 66708 Newton per meter square. This is the pressure at the bottom of the surface of the tank, sorry.